I was saying it tells me next connection, and I was about to do a mic check, and I realized my boom was up on my headset. So, okay, we're here. I don't really know. Man, I'd like to just that. Well, I guess it's going to do all right there. Um, I can get okay, and I'll actually go through and get things get the Model 57 going here and kind of show some of the adapters I'm thinking of. And I'm wearing a coat. It's a little chilly this morning. Probably not as cold as other places. Oh, and I even left this plugged in last night, and that's not recommended. Um, we go through and okay, let's get off webcam here. Okay, so I'm going to go through and I'll probably do some adjustments for the Model 57 as well. In fact, go through, see how that's going to present itself. Because what I may go through is I'll do the okay. Let's get back up on the okay. Okay, so you'll see it just as this. The the way I got the system, and I probably picked it up about a year ago, a couple hours away from here, my from my surplus guy, and of course I have the top down below. It's got some writing on it. It's from the university that's down there in MSU, and I was surprised that I had not gone through and and done anything with it. I'd not even started up or anything like that. And finally, last night I went through and thought, well, it's set off the side long enough. Let's go through and try it. And it was giving me configuration errors right off the bat. It told me the battery was flat, which is not too hard to replace on these systems. Just with another 2032, at least it's a later model of a PS2. And so I got the battery in and went through the configuration. It does have an IML partition on there, which is really nice. But the operating system side was just wiped clean. And I'm thankful in a way that just the operating system side was wiped clean, just the remainder of the disk, not the IML partition, although I could have gone through and created it. This is an 8557. What I'll do is I can pull the case cover off. And you can see, like I say, the markings that I'll go through. Let's get that down. Okay. So you can see all the scribbling, grease pencil stuff there. And It's marked as a 46 SLC2 upgrade. 2 to 16 megabyte. They come Etherlink MC microchannel IDE. And it is actually wrong that it doesn't have an IDE drive. There's the nmsu.net sticker. And it does have some marks and things like that. I've cleaned this. This cover could be cleaned a little bit more. And that grease pencil will come out with a little bit of scrubbing, magic eraser. So this is actually, as I said, it's 8557. It's actually an SLC, 36 SLC, 20 megahertz for the planar CPU, but it has a daughter card upgrade in there. And the let's just set that down there. And the so that 46 SLC2 runs at 40 megahertz. It's double the planar clock frequency, and not at the full 50 megahertz that's capable of in this case. So, but that's fine for this. We're actually going to go through. It does have that 3COM Etherlink board in there. I'm going to go through and replace that with a token ring adapter straight off the bat. We'll run through the IML and get the system configured, and using that or with that token ring adapter fully configured before we even go through and install the OS. I'll go through some of the boards that I have, and so we'll actually go through. Let's power that down. So the token ring adapters that I have here, you probably pulled that one out, kind of set it aside for now. And I think I have these stacked otherwise. I did go through and I put some of these chips over to Ken Schriff, and so I've actually got some extracted from these boards, just with the heat gun, going through and extracting the main ASIC chip, just to get a little bit of information. I do have a bunch of these boards. They're still on eBay. I think these boards have been on eBay for forever at low prices. There was a lot that came out initially. We'll do one of those adapters. I may actually go to having one of those later adapters at one point, but I want to get an example of these. Okay, so we got that. And these are effectively the 16.4. I may need to get my glasses and put them roughly in an order of presentation. And I've got some of the older ones. Yes. Okay. Get one that looks a little bit more pretty. Some of these ROMs are relatively scratched up. And okay, we've got the later ones. I want to get one of the early ones. I should have sorted these a little bit better before when bringing them here. Oh man. So where is an older adapter? Just as an example, okay, that's a Busmaster. 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 Okay, these are Busmasters as well. I know I have one of the earlier adapters. Oh, there we go. Okay, putting these down to the side. Let's see what that one is later on. Okay, and I'll go through and I'll bring up the page. And I'm going to go through and I'm actually going to bring up the Facebook Token Ring group as well, just in case anybody wants to join that. And okay. 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 Yeah. Yeah. The token ring is an interesting aspect. And of course, there's a lot of there's a lot of information about why Ethernet won out in the end. And okay, so there we have the token ring group. Now I'm going to bring up the Ardent tool as well. Oh, come on. I don't know why it wanted to go through and blank my screen. In fact, we'll bring, okay, network adapters. And we're going to go to the 16.4, and what those are, these are identified as 16/4. What that is basically is that it's capable, it's the later adapter, it's also capable of the 16 megabit per second, in addition to the earlier introductory 4 megabit per second. Okay. I don't know why I have my one display is kind of going through, freaking out a little bit here. Let's get the, I didn't have to do that. I can do that. Okay. Oh, what's new in Chrome? This must have done the Chrome update. Okay. Okay. Let's go through. I had this enlarged at one point just to show up a little bit better. on the background. We're going to go to the Ardent tool. We're going to go down to network adapters. And right away at the top of the network adapters is the token ring. Ethernet entries are down below, but we're looking under the IBM entry. And there's the token ring network adapter A. This is the earlier 4 megabit per second adapter. Okay. And then we're going to bring up the 16 megabit capable adapters here. And going through. Okay. So let's get that off. So this is the initial, and as we can see on the back bracket, there's this marking, and they've got the DE9. It's a DE shell, basically, for the D sub connector. 9 pins. The 4 outer pins are used for the cable. And this is the older style of the so-called Type 1 cable. And you have that green dot with the 16/4 on it. That's a marking the token ring of the 4 megabit or 16 megabit rate. There's the FRU of the board, as we have in the back here for, man, focus. My focus is really, it looks kind of I can understand how the monitor's way there in the background, but that looks very, very out of focus for that. So on the board, and this is when IBM went to the so-called or what these are identified as ASICs. And it's an integrated chip that handles quite a bit of the chip functionality. As IBM went in there more, of course, they're reducing this PCB and the support chips to smaller and smaller sizes. And, but this is actually, yeah, we can't, and it's really, really hard. It's a challenge to get the lettering to show up easily. But that's one of the earlier Spyglass chips. This is codenamed Spyglass, and it actually has a this is called the C-Hex that's here. It's basically a driver chip for the connection. And then you have the microcode ROMs. And I've gone through and created a chart and started to sequence these out. And then this socket here is for what's called the Ripple ROM, or basically the boot ROM chip. When you populated the socket, you had it had code to go through and boot over the network instead of having like a local drive on the system. We'll investigate the Ripple stuff a little bit more. I'm going to talk about another special set of ROMs later on as well for the token ring. But this was effectively the first 16/4 in the microchannel form adapter. Looks like a little bit dirty contacts and things like that. I'd have to go through and clean that board up if I were to be have it be to go through and use it, but it does look in pretty good shape. And these are the so-called long adapters, and this is when IBM went through, since they were already had a long PCB, they went through and had this blue tab for the extended, so that this could go through and lock into the case or the front of the adapter supports. Okay. So let's set that one aside. This is the next iteration. You notice that it looks very similar, with the exception of the C-Hex. And it's gone to where there's 2 driver chips that replace that. And IBM did that to where the boards, the adapters with the C-Hex, and they had it on other bus adapter types as well. But in the later versions, they went through and just replaced it with a common, more commercially available chip from National Semiconductor. And National Semiconductor kind of comes in play a little bit later on. The ASIC is one of the Spyglass variants, but I'm not. Oh, that's a real good angle there. But this is another Spyglass chip. Yeah, that really shows up the lettering with the lighting at that angle. And then still the 2 microcode ROMs and the vacant boot ROM socket or Ripple ROM socket. And still, of course, the same marking and everything else on the back bracket. Just a little bit of, one basically slight change between the 2 adapters. That's really the only change otherwise, and just that evolution. And amazing going through and retooling that whole PCB for just effectively the change of just one chip. So next, it went to the so-called short adapter, and where IBM really reduced the length of this, and the ASIC chip handles much more of that, of the circuitry of the board to make the to allow the PCB to be smaller. Same back bracket, but we're going to show the chip just like it did before. I'm trying to think on what angle. Okay, so that 02G1394 ESD, and this is ultimately the chip that's codenamed the Pine Grove. And so it looks like the Pine Grove from the Spyglass era chips really reduced a lot of the other circuitry of some of the other support chips. We do have the 2 microcode ROMs there, but you notice that boot ROM chip, or at least the socket for it, is gone. It's removed. And that is because that is integrated into the microcode ROMs. And this is probably the adapter I'll go through and install to go through and work with, just for it being the Pine Grove level. And it's a good, it's a kind of the middle adapter, as it were. So we'll have that set off to the side a little bit. Now, for this adapter, and you could say, really looking at things, nothing has changed otherwise to these adapters. They do have separate, well, actually, that's the same FRU. So, I mean, these are, of course, the equivalent chips. That's the Pine Grove. And this chip in here is actually the Pine Grove Shrink, at 50G6144. Now, what I should have mentioned down here too is this lower sequence actually has the date code of the chip, and that leading one is always there, but the 9334 that starts out with, that is the 1993 and the 34th week. So we get some idea of when you do look at the chips to get a little bit of idea of production. Still trying to get that. Okay. We see a little bit of and so that's, 1992, 29th week on this. And of course, the earlier ASICs have earlier production dates. But the Pinegrove Shrink was a shrunk version of the Pinegrove die. So just the same die, just reduced in size, the micron level of the die to make it slightly smaller. And I'll give the links to, since we're covering kind of the Pinegrove and Pinegrove Shrink, I'll give links. I'll also give a link to the earlier Spyglass stuff from Ken as well. I'm going to give another supporting link here. Okay. Nobody's saying much in comments or anything like that by what I can see. Okay. Okay. I think that this one is and let's give okay. Okay, let's give that one. Okay, so this is on the earlier Spyglass. This is Ken Schrift's blog. Wow. I don't know why it's going through and adjusting my monitor, my secondary display here. I just did a paste. There's engineering. Okay, let's look. Okay. And this is for the Pinegrove Shrink. And I just sent Ken the Pinegrove itself and some other versions of the Spyglass for him to kind of check out a little bit. But if you go through and view those blog entries, Ken gives a really excellent showing of what the die looks like and how it is on that ASIC chip. And so it's an excellent reference to the composition of that chip, of going through and combining all that. And of course, his examples, he's going through and tearing down, that's the 8-bit and the ISA versions of these boards. But it really has the same parallels on the microchannel side as well. So let's go through and okay. So this is one of the same boards, and I went through and I actually could go through now with this this assembly. I could go through and put the tab on the front, make it look a little bit more complete. Now this looks the same. In fact, it's got that okay. So it has that Pinegrove chip on it. And I went through to typically have a little bit more of the since this adapter was pretty common out there, I went through and I would get the Pine Grove version of this rather than Pine Grove Shrink, even though the Pine Grove Shrink had a later ASIC on it. It should have been improved performance slightly and everything. But this Pine Grove adapter, Pine Grove based adapter, under Windows 95, it was really good. And the Pine Grove Shrink adapter, the one with that 50G um, 6144, this had an issue when you went to configure it with Windows 95. And IBM phrased that as non-IBM network software, that you can encounter other errors and things like that with this adapter. So typically, if I ever was going through, I was trying to get the more compatible adapters than I was this Pine Grove Shrink adapter. Even though on a lower level, like we're going to set up this system, it's all going to come out in the same. We're not going to go up to the level of Windows 95. Some of the other software. In fact, it'd be interesting to check that for the modern equivalents, the MTCP and things like that, who Mike Brutman, to really see if there's a difference between these the adapters, whether Pine Grove or Pine Grove Shrink based. But this one, so I have some ROMs on here. Even though, with the one label removed, it's not really any too much worry of that chip being erased or anything else. If I had to, I could re-download the ROMs. But this is actually for what they call the Trace and Performance program. And you just basically, IBM had some ROMs that you went through and replaced the ROMs that they were issued with. This ROM gives access to some software that you can run that goes through and monitors the states of your Token Ring network, Trace and Performance. And there's a separate page at the Ardent tool for that. I'm going to be working with these with the Trace and Performance program a little bit more at a later point. I was trying to go through and show the chip that's there. I think these are 27. Got a lot of gunk on the sticker residue from the label. Maybe even the initial label. Okay. These are, that's really hard to get that to show up. So that's an AMD chip. And I think these are 256 EEPROMs. I'm trying to remember. But I'll give a link to the Trace and Performance page at the Ardent tool. And so I'll be going through and using this adapter to some level later on as well with that Trace and Performance. And then later on, there was what was called the auto adapters that IBM had for the different bus types. And that takes it to the RJ45 connection. Actually gives some link and activity lights, or effectively, and goes through and just really has surface mount chips. And this is one of the later adapters. Auto means that effectively going through and being able to sense what the ring speed was, whether it's 16 megabit or 4 megabit, and be able to synchronize to that ring. Now, it's important to mention that unlike Ethernet, Token Ring is not to where you can mix the so-called ring speeds, the connection speeds that the network operated on. So a 4 megabit adapter that was older would not be able to communicate with the 16 megabit ring or the network speed of the later adapters. You'd have to have matched 16 megabit connections on that higher speed ring, and then your 4 megabit per second ring has to be all workstations and equipment that is on 4 megabit per second. You just can't mix and match like the 10/100. Now, a lot of time you'll notice the amount of components on the board. That won't seem to really be any different from Ethernet. And we're going to pull out this old 3-COM board. Now, it is important as well to mention that, and see, this 3-COM board is even as old enough of Ethernet adapter that it has just the AUI port and the coax port. But you say, hey, this has got the same amount of electronics. It's got a lot of chips on here. But ultimately, the socket for the boot ROM. But ultimately, the Ethernet adapters do not have effectively any necessarily overall processing that the Token Ring adapters do. In these ASICs, there's effectively a 16-bit processor, microcontroller in there that runs from this microcode. And so Token Ring had a little bit more overhead of going through to where the boards were more expensive to produce. In particular, the Token Ring die. Ken Sheriff talks a little about that. You can only test the chip when it was fully on the die. So going through the production levels, if you could have a die that failed and end up being rejected. So the production cost of making that much more complex chip was a little bit more expensive on the Token Ring side. I did even recently receive I should have had it here for the, it's actually an IBM award in resin that has actually a die of the one of the Token Ring chips in there. And that looks very similar, of course, to Ken Sheriff's blog entries of showing how the chip appears on the substrate. So that's the reason that that Ethernet ultimately won. Now, the original Ethernet boards, and with this coax cabling and AUI cabling, Token Ring was really winning at this point because these Ethernet adapters, you would have data collisions as you went through and increased your Ethernet network in the early days, and they had hubs. An Ethernet adapter goes through and does a broadcast to all the over the hub, and all stations are basically listening for traffic. And as you would increase your network, you'd have data collisions because the networking boards would try and do communications all at the same time. If they had a data collision, they'd have to back off for a random number of milliseconds before it retransmit, just in the hope of avoiding those data collisions. But it was a thing that was a pretty predominant problem. They went through later on with network switches as Ethernet got faster, better cabling methods, that they were able to nullify with the network switch the data collisions. that happened on the network. And that was the point where it started gaining ahead of Token Ring for the amount of for just taking over the networking side of Ethernet becoming more common. Token Ring, on the other hand, you have a network of Token Ring adapters. It is a ring, so that part of the name handles things, and so it's just the same effect of 10 people that are holding hands in a ring, but there's a token that's passed around. If you're only allowed to communicate over the network, to talk, if you are in possession of the token. And if you don't have anything to transmit, you go through and you hand the token to the next device or the next person in that ring, in this analogy that I'm talking about. And if they have something to communicate over the network, they transmit that. If not, they pass the token to the next person, and that token continues around the ring. And so you don't have any data collisions. You can have other things like loss of the token and things like that have add a little bit more complexity to Token Ring. But all that processing to go through and avoid the data collisions and handle that token, that took a little bit more of the processing power. And so we're going to go through. Let's get this. Let's get this Token Ring adapter in the socket, in the slot. And we'll just put it in the same slot that the Ethernet adapter was in before. And as I say, this is an IML partition, and it should have the Token Ring okay. So let's go through. And I'm not going to even put a diskette in at this point. Let's go through. Get that switched over to the VGA. Okay. I'm going to go through and actually try and adjust where this shows on the screen, just to get and I have a 4:3 aspect ratio set for this, of course, just like a normal a regular old school VGA. So that we have the 165 error. That's going to be a change in configuration. Okay, and that comes out pretty good. Let's go through. Wanted to get a little bit more. So it's asking if we want to automatically configure the system. I'm going to do Y for yes. The 0 or the 165 error is a configuration. Okay, description for the adapter in slot 4 was not found. So we need to go through and grab that ADF from the Arden tool. I'm going to fire up my other system here, and I have a diskette drive on it. I can go through and basically, and it'll just be that little. Okay. that ADF that we need to have from, okay. So I'm going to the ArtandTool site, going down to MCA adapters and then network adapters, and we're going to go to that. So we're needing that okay. Okay, so we want to okay. So actually we want to save link as okay. And we'll save it to our drive. Let's open up the folder. Find out if we can swish that over to our diskette. Oh. We may have to go through and format the diskette. Okay, send to. Okay, I just used another diskette. Okay. And we will go through and copy an option diskette. Okay, remove the option diskette from the diskette drive, enter. Okay. So when enter is pressed, the system will automatically restart itself. You saw how easy that option diskette was, just grabbing it from the ArtandTool to put it on diskette, switch it over. As long as you have a functional diskette drive, that works pretty well. But normally the token ring adapter was so common with IBM systems that they typically included it on a lot of the reference diskettes for the different systems. I was surprised that that's not there for this IML partition, but it was easy enough to pick up. And so we're going to have to where there's no operating system still on this system. So it's going to go through and give us a warning. What I actually want to do is let's go through and get into the IML configuration. We have you can't see it on your screen because I have the window that I'm at. Oh, that really. So we're going to do, okay, Control Insert when the blinking cursor is in the upper right-hand corner of the screen. And that should get us into the IML partition. Okay. And I want to see, earlier I was going through, okay. So, and I went through and I set the time and date earlier when I went through and replaced the battery. So that's tracking for pretty close to the actual time of what I have right now. Now we could even go through for the startup sequence later on in going through and booting over a network. There's the traces, and we have that entry number 3 is RPL from network. So that's a remote boot over the network. We could go through and set that up, later on with this token ring network. If we have a network server, I'll go fully through, and I intend to have an I-class server that I'm going to get set up for token ring as well. Okay, I was just wanting to go through and do a view configuration to be able to go down to, okay, so there is our token ring adapter. I guess we can go down, since that's in slot number 4, just to kind of get it in the middle of the screen or visible all the way on the screen. It says the primary, the adapter data rate is 4 megabit per second right now. And then it has all the ROM address range, the RAM size, address range, things like that. I actually want to go through, I want to step back out to change configuration, because I actually want to go through and set that up as a, it's interesting that it went through and defaulted to the 4 megabit per second network speed, but that's fine. So we go through for this, as you see with the function keys at the bottom, we have the previous and next to where we would go through, and we want to set that to that 16 megabit per second. All the other entries are fine in this case as the defaults. But I'm going to go through and F10 to save. Okay. And then we'll go through and we can exit. In fact, it'd be interesting. Display memory map. I wonder if it's going to show the, okay, so there it does show the token ring, that shared space basically with the system. And and so that's interesting for we have it set to the 16 KB range, and actually it uses both of those blocks that are indicated there. Apparently just has an entry for the first entry is for if you just have the 8 KB of shared size, the second entry for the 16 KB of size. Okay, and I better get ready with my diskette. We're going to go through our PC-DOS installation. I've been going through with the live stream longer than an hour, and that's fine. But let's go to the point of actually where I advertise this as installing PC-DOS. Got on a little bit of the talk of the token ring technology and chips and adapter types. Okay. Okay, and I think my screen is still set up pretty good. It's going through and it's booting off of the diskette. Starting PC-DOS. Now I do have the Authentic diskettes here. I think that they're all good. So prompted for whether we want to install PC-DOS, we're going to, of course, specify yes. And it does the XDF loading here for the setup. I don't believe I need to adjust that too much more, but let's get it. I'm trying to remember where the memory size as it goes through and boots was showing up, and just getting to the point where I think that's where the screen boundary is. Okay. So, okay. And we're not so interested. We do have a mouse connected, but okay, options are I don't know if I really want to go through and do central point. So let's see, does that have, okay, so no. We probably don't need to do any of these others. I'm thinking maybe Rex, but I don't really think that we need to really change any of these other entries. And it'd just be swapping diskettes at this point. After I have PC-DOS loaded, I want to go through and do some things as well. There's a qconfig program that should be on there for being PC-DOS that actually shows the system and adapter information. Of course, I've run the system information tool, IBM system information tool, on other model 56, model 57 sorts of levels. Okay. So switching to disk 2. Yeah, I really hope that all my diskettes will be in working order. I could go through and install, download this from like WinWorld, but we'll just hope that all the diskettes are going to function correctly. And whether I go through and install something like Windows for Workgroups, maybe. In fact, that's probably likely, as I'll go through and do some of the token ring testing. But I'll do that in, of course, another video. Okay. And we'll get to see how, with some of the later videos, I plan that trace and performance aspect. In fact, I'm still on the hunt for some trace and performance ROMs that were on the 8-bit boards, because I only have the microchannel version right now. And okay, that was funny that it went through for 3 and then prompted for 4 immediately. And we'll see how long it is before it prompts for 5. But yeah, still, I mean, if you want to go through and join the Token Ring group on Facebook, if you can put up with Facebook, and you'll get a little bit more information. I list a little bit of the items I'm searching for in that group of for the Token Ring side of things. There's particular adapters. I'm looking to send a little bit more more chips to Ken Schrift for more disassembly. He's working on some of the ones that I've sent just a few weeks ago, and he's provided some initial images to kind of show some code name investigation is what we wanted to do. And so there's adapters and a little bit more. I know the local area network program was mentioned earlier. There's some DOS level stuff too. And as I say, Mike Brutman does a for his TCP utility of getting effectively getting a DOS system onto a internet with an IP address, basically a network, not necessarily internet, but a network. And I'm interested in kind of checking that out a little bit as well. Okay, is that 100% complete? We'll see where it goes. Okay. Options are correct. Okay, remove any disk from the drives. And then press any key. So we should have PC-DOS installed on the system at this point. Now I have another few adapters off the side that we can probably get into at a for another video of going through and talking about the Tropic chipset of what Token Ring turned into and how IBM had National Semiconductor kind of market that to other manufacturers. But we'll get into that in another video. I want to go through and just as a final thing, and okay. just looking over some of the files, or all of the files within the DOS directory. As I scrolled through, there should be a qconfig program. Okay, so we're going to need to do a little bit of the more typing here. So this is IBM PC DOS version 7.00. List of date and time, model ID F8, BIOS revision, and it lists the machine type as a PS2 model 55SX. You know, ultimately this is a an SLC CPU. It's on the planar that, of course, is not. It's in a float condition. It's not working. It's bypassed basically by the 46 SLC2 daughter card that's on there. And it's interesting, it has an estimated speed of 20 megahertz. This should be running internally at 40 megahertz. Processor code A4. All that means is really basically a 486 class CPU as far as instructions, although the SLC is kind of it's in the older 386SX architecture, or that pinout. In other words, it's limited by the amount of 16 megabytes for the maximum amount of memory, and a 16-bit external bus of the CPU. So it knows it's on a microchannel system, and it did even go through and look like it loaded the mouse.com driver. I do have a mouse attached there. Of course, we're not in a window where we can use that mouse functionality, but shows the equipment that's to the system, and at the very bottom it lists that token ring, 1 adapters, primary token. It's got the ports and the ROM. All the information there as far as what that token ring adapter is. And it finishes, of course, with the all the other information: SCSI device, primary video, the diskette drives, the hard drive, and the memory. And then has the a showing of all the expansion slots. We only have that token ring adapter loaded in the for expansion slot 4. So yeah, we've gone through and installed PC DOS. I've got that token ring adapter installed on the system for a little bit more. Okay, yeah, the qconfig/d. And of course, we'll probably still do the piping of the more. We should have done an insert to get. I don't think I need a space after the pipe, but okay. So okay, I'm looking for a little bit more. Okay, so yeah, expansion slot 4 gives the POS data, how the card is configured, and that's the primary adapter, etc., adapter speed, and so yeah, that does give a bit more information on the the token ring side that we saw in the card configuration as well. So, but this seems to be a pretty good place to wrap it up for mission accomplished on getting PC-DOS installed in the system, getting an operating system back on there after I've had it for an entire year, just kind of sitting off to the side. And we'll use this this system to go through and do a little bit of a investigation on the token ring side and see what we can learn. But thank you all for tuning in. Looks like we had a pretty good audience level here for this live stream. I'm trying to get back into doing these on the Saturday mornings again for me. Well, Saturday morning for me. And so I hope everybody enjoyed the content, and we will have more videos, more live streams coming up. But I thank you everyone for tuning in and watching. And so this is IBM Museum. That's all I have for now. Thank you.